one, read the announcement. COVID is rearing its ugly head again. So, read the announcement. There are no repeats of any exams. That's why I dropped the lowest exam score, so that you have one free, non-taking, or low score of an exam for all students. That's in the announcements. I also published The World's Most Interesting Man that I told you about last week. I went and found it because I realized I haven't posted it in my cubicle lately, so I did that too. Tonight, we're going to have 3 weeks from tonight, exam 4, November 16th. Right now, we're going to have specific questions in just a minute. Then we're going to take exam 3. Then we will do lecture and lab repeatedly, covering as many of these subjects as we can get. Okay, starting in the very back row on my left. Questions?
Can I ask a question?
Yep.
If we're writing code, do you expect us to put prototypes in our code?
Only if needed.
So what, well,
Or unless I specifically ask you to.
okay, because the textbook says it's best practice but not required, because the compiler puts it in for you, right?
Not really. The compiler just keeps track of it in a symbol table of what it has seen.
So
The reason it says, go ahead. I was going to say the reason they call it best practice is because it is best practice to put all prototypes in a .h file so that you can give that to somebody else so they don't have to have all your code or don't have to worry about all your code. That's the reason it's best practice, because when you get to any programs of any size, it's like suppose you wrote a library that everybody's going to use called Andy.Live. I'd give out AndyLive.h. And then they could use that, and I'd give them the DLL. They wouldn't get the source code.
Oh, that makes a lot of sense, because then if it's just a small, like, pedagogical program, then it's not necessary, really.
Right.
Okay.
But if I specifically say, write a prototype for this kind of function, then yes, I would be expecting it. But I would be very clear about the expectation. Next to last row on my right. Okay, side row on my right. Question?
Yeah. What's the difference when you declare a function versus when you define a function? Like, in what case would you use which?
So declare, in all cases, typically means you have the name that you've given it, be it a variable or be it a function. But in terms of function declarations, a prototype that has no body, it simply has a semicolon, is frequently referred to as the declaration, whereas when you then supply the body of that function, this is typically referred to as the definition. Now, unfortunately, the terminology is not consistent. Because in Visual Studio, sometimes, you'll say you can keep the definition without leaving your page, and they call that this thing the definition. But for our purposes, this is the declaration, this is the definition.
If you have a definition like later in the would you need to define it first?
You need to declare it?
I mean, to declare it first.
In other words, is this required? No. Not unless you refer to it before this. So in other words, here's an example, so let's just maybe have an example here. If you try to compile this, forget all this over here for a moment. Forget all that. If you tried to compile just this, would it compile? Who thinks this wouldn't compile? Raise your hand. Most people think it wouldn't compile. So why do you think this might not compile?
Because my func is not defined.
That's correct. The compiler starts here, goes here, gets to my func. It says, What's my func? I've never seen my func, because it's down here. So if you put the prototype up here, my func, you've told the compiler all he needs to know. You've told him the name, my func, the return type, and the parameter list. That's all the compiler needs to know to make a call to my func, or to generate a call to my func. So now he's seen my func, now it'll compile. You can generate it later. Related question?
If you were to say return 3 and then in the prototype, does it know that it's returning 3?
No.
Or does it?
No, the prototype, it doesn't know computers don't know anything. They only know what you tell them. Did you tell it anything about that? No, you just gave it a return type, the name, and a parameter list, which happens to be empty in this case. It's the only thing you said here. No magic. Related?
Yeah.
Yeah.
What's the difference between a signature and then that prototype? Are they the same?
This is the signature, the return type, the name, and the parameter list. That is the signature. You see you see the same signature in both places, because you have to. The signatures have to be identical.
Okay. But then the whole the method as a whole being like created before that's the prototype?
This is the prototype.
Just the my func and the parameter list without the
Yep, this is the prototype. It's simply a placeholder to tell the compiler this thing exists. The compiler doesn't care at this point what it does, because that's going to be compiled later. But he cares that he's going to make a call to it. So he has to know when he's calling, what the parameter list has to be, so he can generate any errors if you get the parameter list wrong, if you get the return type wrong, and so forth. That's why you have to have the prototype. Think of it as a placeholder. Like, %d in the printf statement is a placeholder. It doesn't actually contain the actual thing. It says, put the actual thing here when you get it. This is like, a prototype is like a placeholder. Okay, next to the back row on my right, question.
If you were to have a for loop with a scanf inside it, when would the variable that you're collecting from scanf update?
So you're saying something like for int I equals 0, I less than 3, I plus plus, scanf, what goes in here?
So, say you define a global variable,
Let's just say an int x.
when the user enters an input, the next, or like when would that input be updated in the global variable?
You mean when does x take on a value? As
Yeah.
soon as this statement's executed, as soon as this method is executed.
And if you were getting a 0, what would be the problem?
Getting a 0, you mean a value of 0?
Yeah, after the scanf, even though it's not entered 0.
I have no idea. I mean, it's very specific to whatever program you're talking about. But I guarantee there's something causing that. Perhaps the wrong placeholder was used, perhaps the wrong variable type was used, perhaps the scope of the variable is, well, no, you get a compiler then. I don't know. Question?
Yeah, in exam 2, I didn't understand the problem where the answers were like 0, 0, 1, 2, 0, 0, 1, 1, 2, 3, 3, and then a specific number, either 5 to 6 and 8, could just be 5, 6, 7, 7, and 8. That how I didn't understand.
You should have asked after exam 2. I didn't understand any of that question. And I don't remember what exam 2 had on it exactly. In other words, you can't, that's not a specific enough question. Question?
Right.
One more time?
For the pointer variable, you have to ask it closer to the variable type or the name.
Oh. question is, do you put the star here or the star here? Star here, it won't matter. You put it, as long as you only put one. You put it right next to that, put it right next to that, you can put it right there. It won't care. Okay, any more questions? Questions?
How do you pass by reference an array? Like a array, for example.
How do you pass an array by reference? Okay, so let's suppose you had, so there's two questions, there's two parts to that question. How do you declare the parameter to pass it to, and then how do you actually pass the parameter? Okay. So let's just make it empty bodies. So there's two ways to declare the parameter. You can declare it as an integer, pointer. And then inside of here, if you say, you can take that pointer, index the pointer, that the index dereferences the pointer and goes to index 1. So that's one way to do it. The other way to do it, this doesn't change. The access is the same.
Could you put the brackets like in front of the RE variable?
You move them over here.
Or I mean the parameter. Can you move them in front of it? Of the parameter? RE? Like after it. Yeah, right there.
I don't know. I'd have to look it up. Most people do the pointer syntax. You call the function. Call the function. We already have that thing declared up there. That works because without a subscript, it is a pointer. That also works. With array sub 0, it's the first element in the array, you're giving a reference to it. And the rest of the array is behind it. Okay, any other questions?
So does that only update because the function is only updating the first, well actually the index 1 of the array? Is that only updating index 1 when you...
This statement?
Yeah.
Yes.
Okay.
But you could have array sub 2 equal 14 or whatever, and it updates index 2. In this case, if you said array sub 3, what would happen? It would stomp on somebody else's memory is what it would do, unfortunately. But it would not be valid, you're correct. Any more questions? One more time?
How do you pass by reference a string array?
A string array?
Yeah.
This is the same for any array.
Alright.
Any type of array, same rules apply. Okay, everybody lower your computers. Put everything away. Before we continue on from last week, someone said, why are the tests harder each time? Who can venture a guess as to why that is? Nobody? Why do you think the tests are harder each time? Because the material is cumulative. That's right. That's exactly right. In fact, they are not harder. They are just perhaps, well, no, they're harder because they're more complex, because they're cumulative. I can't think of a better way to say that. So in other words, you have to use pointers and know about pointers and understand how pointers work, as well as methods and functions. And on the next test, you'll need to know all that, plus structures. And quite possibly, I haven't looked at the test in the last 4 days. Not all of it anyway. String methods that we'll talk about. If not tonight, then next week. Structs continued. Let's talk about structs that we did last time. What is a struct? Okay, so guess. What goes inside a struct?
I dumped all the information in my brain to study for the exam.
Ah,
I don't remember what stress,
you will not survive as a programmer.
unfortunately.
Because you can't dump everything. Right? You keep some of the basics, some of the important things.
It gets added back in later after the stress. It's all
I know, everybody tells themselves that. It's like the famous concept of code debt. So we will diverge for a moment and talk about code debt, which is similar to memory debt, if you will, right? So, we had written this thing to take care of renting apartments or advertising apartments in Canada. So they didn't want to do the right thing, and I finally got them to, rather than call it a kludge, to call it a convenient implementation. That's the best I could get out of them. It was a kludge and a crowbar. But fine, you pay me, you tell me to do a kludge and a crowbar, I'll do a kludge and a crowbar. And sure enough, like I told them 2 weeks ago, it came back to bite us today, right? Because they did the kludge and the crowbar. A kludge and a crowbar, everybody knows what a crowbar is, right? This big piece of metal. Okay. Going back one more time. If you have a lever, who said if you give me a long enough lever I can move the world?
Archimedes?
No. Well, you know what? He may have said it first. Some guy said it. If you have a long enough lever, why does a long lever allow you to move things with greater facility?
Leverage.
Leverage, from the word lever. What is leverage?
It's like the advantage that you have because of the way that gravity works or the way that physics works with a lever.
This is your lever. This is the fulcrum for your lever.
Is it like torque makes things easier to lift something?
Torque is essentially rotational leverage.
Yeah, but if you apply force on like the longer end, then the torque is constant, so force would be increased on the shorter end.
So let's suppose this is length 1. Let's suppose this is length 3. Okay? And what you said is correct, but the question is why. Right? So here is the why. Okay? If you move this down 12 inches, which means you have to apply 1 inch of force at a time, let's say. Because the ratio is 3 to 1, it moves this up 4 inches. So the net result is, okay, you have more movement over time here, whereas you get less movement over time, but you get time. So the net force you have to apply here is less, because you're applying it over a greater time. Okay. So, leverage, if you will. So there's all kinds of levers, right? This is a very simplistic lever, right? Torque is when you have a round lever. Gears, everybody hear about gears? You guys don't drive stick shifts anymore, but once upon a time you used to grind gears. Because you're sticking a tooth circle into another tooth circle, right? And that's how they work, is because how fast do they transfer momentum? Because if you look at your, there's a name for the thing that says how many RPMs, revolutions per minute you're having. One more time?
Tachometer?
Tachometer, thank you. Yes, tachometer, right. He knows all these things. He knew about the world's, what was it again? The world's most interesting man. Yeah. It's in your announcements. I even printed it out and stuck it on the wall next to my desk. For everybody who, I showed it to the QA people. I said, this is why you have trouble, because I believe this. And since they know me, they know I don't really believe them. But, okay. Pulleys, where you pull on a pulley, and then it goes through multiple pulleys, so you have 5 or 6 lengths of rope through the pulleys. That's another form of lever. It's just in a different form. Look on some of your old sailing ships, right, in the movies. You'll see the guys just pulling on this thing as hard as they can pull, but the sail is going up very slowly. Same concept, right? He's using a little bit of momentum over a lot of time to move this slowly. But it does move it, and it lets us, as human beings, do many things Even cars. Cars work on the same principle. Gears are essentially another form of levers. But, how do we get to there? Oh, because weeks ago they said, yeah, put this crowbar in. A crowbar is a lever, right? That's how we got here. A crowbar, think of this as a crowbar. You're doing something, small at a time by moving it large here over time. So that's what coding is, right? You can either code and put in a crowbar, and then it'll cost you later, right? Because then you can't reuse that. Remember when I said to you, DRY, what does DRY, dry, stand for? Don't repeat yourself. Remember we use that as the reason for methods. So that you can write it once in this method and then call that same method multiple times. Don't repeat yourself. Okay? So the problem that was given to me today that they found is that someone had repeated themselves. So we fixed a problem in one area, not knowing we needed somewhere else to go fix it. How would we know to go look? We wouldn't know to go look, right? So somebody else had already repeated themselves. So I got together with my buddy Christian and I said, just make sure I'm not confusing myself here. And I drew it all out on the board and he said, nope, you're right. What they did there was wrong. We need to talk to them harshly. He was kidding. Well, I'm not sure if he was kidding, but I said, well, let's wait. Let's see how long it's been there. If it's been there a week, yes, we're going to talk to them harshly. So I went and looked, and it had been there 2 or 3 years. Nice. At least 2 years. There were different dates. The most recent date was 2 years ago. Okay. So no point. So the guy's gone. That's the better part, right? He's gone. It's not his problem anymore. Okay, fine. So it's my problem. So, a couple ways we can fix it. The best way to fix it, the most correct way to fix it, is to eliminate the previous repeating yourself. So that's what Christian and I wanted to do. And we said there's 2 different ways to do this. But Christian, being a politically savvy person, said, but we should run this by the boss just to make sure. So I said, sure. So I laid out both options. We can do it this way, solves the problem, we haven't repeated ourselves, or we can do it this way, solves the problem a little bit differently, still eliminated the repetition. So what answer came back, do you think, from the boss?
I don't care, do it.
No, that would have been great. I love that answer. Oh, cool. Right? It's up to me. Because I know what the right thing to do is. Right? But what came back was then repeat yourself again. So Christian and I looked at each other and, okay, they're perhaps not paying me enough to care, plus I'm not that far from retirement. So I just repeated myself. And the boss was right. It was much easier to test, because I only had to test the thing I repeated. I didn't have to test the other stuff. But the next guy, 6 months, a year down the road, is going to curse me until he reads the code, because I will put in comments in the code that said, repeating myself upon direction from management. I will literally put that comment in there. So that when they look and see my name, they say, oh, it wasn't him, he was told to do this. Okay. So, struct. You've had time to think about it, you've had time to read furiously, and your conclusion is, what goes inside the braces?
Variables?
Variables. Well, not variables exactly, but, well, they're variables. Type definite, type with a name, right? So they're official variables. So you can put here, C. Let's make it meaningful. So forth. And you can group things. In your programs, when you get to program 4 perhaps, you have to do all the stuff you did before except regroup it into structs. And that's why. So you can see that now we're making a nice little struct to this person. You may want to give it the struct the name. We're going to make all this a little easier when we get to type def, but you may want to give it a name, struct person. There you have it so far. This is what we went over last week. Any questions so far?
When you name a struct, not like you have that struct, but then you can make an actual instance of a struct, right?
Yes, this is a type.
Right. So then, can you name it with a variable that is, or like, can you have a name input by the user and then name it like in one line?
You mean this? Input by the user?
No,
The name of the variable you want, so let's suppose you want to. That's what code data is, by the way, is when somebody's going to have to go back and fix it, and you know it. Code data is almost never removed. It's very sad in our industry. So going back to his question, so you want to declare, so that's declared a variable named P of type struct person.
right. So instead of it being P, could it be a user entered?
No. You cannot give a variable name. A variable name has to be static. The way you make them not static is you make arrays of them so that you can index it, but you're still indexing a fixed name that you chose at programming time, at coding time, not at runtime. I thought you were asking me a different question. So, for a struct person, and yes, that needs a semicolon. I left it off for a reason that we're going to get to in a second. Okay, I've declared, this is the type name, struct person, right? That is similar to int, to char, to float, what have you. That is the name of the type of this variable. Now, as we saw with enums, remember when we had enums, you could say, as you guys saw, I could barely draw a lever. DOW, days of week. Now remember, with enums, that is sufficient to declare an enum. And then I could say enum, and that would declare a variable named day, where that being the type. And if you will recall with enums, in addition to declaring the enum, you could also instantiate or declare a variable. Now this is unnecessarily, in my view, complicated. If it was up to me, you wouldn't be able to do this. You'd have to do this and then this. And then the later programming languages, that's what they enforce. In C# and Java, you can't do any of this stuff. You have to do declaration of the type and then instantiation of the type. But we're dealing with C here, so this is what is allowed in C. You can declare the variable right after the type. Similarly to how you can do this with the enum, you can also do this with the structure. You can also declare a variable named person as you continue to declare the structure. It gets even better. And yes, you need to know all this, because there you have not only declared the structure type named person with a capital P, you have declared a variable of type struct person with lowercase person. Let's just change this to make it simpler, so we don't have any confusion. So we've declared a type called struct person. We've declared a variable of type struct person with the variable name Andy. We've declared another variable of type struct person pointer with the name pandy. Just like you can do with enum, you can do it with this.
If you're allowed to declare a pointer, why aren't you allowed to declare an array that's dynamic? Because my compiler wouldn't let me do that.
Well, yeah. when you say dynamic,
So just above the struct person, I put like int x equals 5 or something, and then below I put p Andy, and then in brackets or whatever what the name was, the variable x. And so it said I wasn't allowed to do that because it was dynamic unless I removed the variable and put the number
we
5.
might be diverging a little bit, but let's write that down real quick. So you said int x is equal to 5 and 1. And how did you try to declare the array?
So instead of putting p Andy, I just put the brackets without the.
No, just forget that.
Oh, okay.
How did you try to declare the
I
array?
just put array brackets x.
The word array,
Sure.
you have to give it a type.
But if you declared it under the struct person, you don't have to write the type, is what I was saying. I mean, if you did it right within the declaration of the struct, and you put the int x before the struct, it wouldn't let you declare an array dynamically of structs.
Let's take that up separately.
Okay.
I think you're confusing multiple concepts, but let's take it up separately because I don't want to confuse all that.
All right, fine.
I'm not saying you're wrong, I'm just saying I need to look at it in more detail about what you're saying.
Okay.
Let's stick with this. So this works just like enum, right? Enum is a more complex type that you're declaring, and you can declare variables at the same time. Similarly, with structs, you're declaring a more complex type that has inner pieces. And you can also declare variables of that type at the same time. You'll see this in old code. You won't see much of it in new code because we're going to move on to type defs in a little bit. Any questions so far about how to declare a struct? Now another thing about structs that you need to know is most variables inside of a struct are padded such that the variable starts on a word boundary. A word boundary will be a word for that computer. So on a 32-bit computer, a word is 32 bits, 4 bytes. On a 64-bit computer, a word is 64 bits, 8 bytes. The reason they do that is because it gives you a lot more speed in memory access. It's a lot faster to access something that starts on a word boundary. Because if it doesn't, you have to do multiple accesses. Or you have to do an access and then bit shift. You have to do all sorts of extra things if it doesn't start on a word boundary. So just know that this would be 1 byte, 30 bytes, and let's just say this is 4 bytes on this computer. So you would think it would be 1 plus 30 plus 4. This struct would take 35 bytes. In fact, on almost every computer system, it wouldn't. This would take 1 byte, but then you would have 3 bytes of padding. This would take 30 bytes, and then 2 bytes of padding. That's just what actually happens. You can actually go prove this to yourself, if you care to, by declaring a struct and doing a sizeof struct and see what comes out. See if it comes out to be 35 or if it comes out to be, well, this takes 4 bytes. Or if it comes out to be 40 bytes. So I'm going to ask you, what is the size of this structure? You should assume that it's doing padding because almost all computer systems do. And then you have to figure out the word size of your machine. Or be told the word, you don't have to figure it out. You have to be told the word size of your machine because there's no way for you to magically know that. But the important point is that everything is in the order that it is declared in memory, but padding is added in between fields within the structure to align to a word boundary. That's the important thing to remember. So remember earlier on when we said always use sizeof to determine how big things are and how big Now you know why. So for arrays and ints, it was fairly trivial, right? No longer trivial. And no way for you to know. That's why you use the sizeof operator to figure out the amount of space to allocate.
Sorry, why is the padding there? Why is the padding necessary?
The padding is necessary to make it to start the field on a word boundary.
Okay, I see.
Because the memory access is much more efficient starting on a word boundary. That's just how computers work. That's how the hardware works. And at the end of the day, everything is optimized for that hardware.
And you said in a 32-bit system, then it's 4 bytes per word boundary, and then in a 64-bit system, it's 8.
It's 8 bytes, yes. But on here's another wrinkle. See, on 64-bit systems, they implement it in different ways on different chips, right? One of the things they have on 64-bit chips, it's called a chip processor for want of a better word, they have an emulation mode. And the emulation mode says, treat this as though it's the 32-bit word. And that's complexity we don't need to worry about. Maybe ever. But for our purposes, the important point is that padding almost always happens, and to use the sizeof operator to properly calculate things. That's why the sizeof operator exists. The sizeof operator primarily exists to make the C language hardware agnostic, i.e. it doesn't care what piece of hardware it's running on, it's going to have the same definitions. As long as you use the sizeof operator so that you don't have to know. That's everything we covered last week, plus a little bit more about these variables that someone had asked me, but we hadn't quite got to them yet. There's another thing someone asked me about pointer reference that we're going to get to in a minute as well, because it becomes relevant for structs. We'll get to that in a second after we talk about initialization. Now, if you will remember, you can initialize an array. Just like you can initialize an int. You can say int x is equal to 3. You can also say, you can also assign values to an array after you've declared it via initialization. Everybody with me so far? Similarly, you can initialize a struct by giving its members values when you declare it. So let's do this one. Why can I do it like this? You can tell me why I can put it on other separate lines. White space doesn't count.
Yeah, white space.
White space doesn't count. That's why. The first character, let's suppose we're going to initially assign this person P a grade of A. What do I put here?
Single quotes and an A in it.
Okay, let's suppose I'm going to give this person a name. I'm going to give him a name. And let's suppose I'm going to give them a numeric grade of 95, which is an A. What's the next thing I would put? 95. With no quotes. Why are there no quotes? Because it is an integer. So you can initialize a structure in the same way that you can initialize an array with the pieces you're giving to it, except you have to give it the pieces separated by commas in the proper order.
Should there be a comma after 95 or not?
You shouldn't. You should not. I don't think it would compile. But I can't swear to that, because there are some things in modern languages where they recognize that you may be adding to the list, and they allow you to put, for instance, in C#, you can declare an enum the same way, and you can absolutely put a comma there.
What about for C?
For C, I don't know. So let's say just do it the clean way and leave off the comma for the last entry. I think C gives you a compiler, but I'm not positive about that. But I think it does. Remember, you always have implicit homework. Just because I cover it up here doesn't mean you have it. Go study, go read, go practice. Write little programs and do nothing except declare structs, operate on structs, and do things like that. Okay. Sure.
What's P equals to on top?
This P is equal to this initialization expression. Because he said you don't have to have, you don't care about
White space.
white space. White space is spaces, tabs, and new lines. You don't care about any of that, except inside quoted string. Except for that, and this makes it nice and clean. Just like with the enum, you almost always see it this way. You almost never see things strung out. Why? This is simpler to read. Human beings are pattern matching. Our brains work on pattern matching. We process lists vertically much better than we process comma-separated lists horizontally.
Is that the one on the right side half of the board a continuum of the first left half?
So this is declaration of this structure type with an initializer. And when you go look carefully as you do your implicit homework, and then actually write little programs, you're going to see how it works. And your little programs will give you syntax errors so you get it right. By going back and reading the book, trial and error isn't enough. You need to go back and read the book so you understand why you got the error. And then correct the code because you understand, and then it'll magically start working. That's a joke. There is no magic. There is no magic. There is no magic. Yes, sir.
How do we access the variables in the, or like the values in the struct if it's declared as it is in the right?
That's a better topic to get to, actually. Okay, let's talk about how to access the fields within a struct. Okay, so we've declared the structure type. We've declared a variable named P of type struct person. We've actually filled P with some values. So here the question is, how do we get to those values? Exactly a good question. Okay, that's the first part, P. What do you think follows it? Take a guess.
Bracket 0, close bracket.
That's not a bad guess, that's a reasonable guess, but it's not correct. So instead of an index operation, you're doing a subfield operation, which is a period. So what do you think follows the period? We're getting the grade out. It's more intuitive than that. The name of the field. P.grade. This is important to keep track of because as you move to C++, to C#, to Java, JavaScript has this, TypeScript has this. I can't remember Python at the moment, but it all has the same syntax. Variable name dot subfield name to access the subfield in whatever fashion you're accessing. So we've assigned P.grade to a character variable grd. So let's suppose we wanted to assign a pointer to the subfield name inside the variable P. How do you think we would do it? Here, we'll do the easy part. What do you think follows the period? Name.
And then you add an ampersand before it, right?
You would not have to add the ampersand. Why would you not add the ampersand?
I would think you would add it because you want to reference the pointer, right? The car pointer.
You do.
Oh, but it's already a car pointer. Like, name is already a pointer.
Name by itself without a subscript is a pointer.
Oh, okay.
Suppose, have you noticed we're always reviewing pointers one way or another? If I said name sub 0,
I see.
That would be a specific character, and I'd have to put a reference operator in front of it then. Always reviewing pointers.
If it was just p.name, so 0, would it return just the first, or the character, well, the first character in the array?
It would return the character with whatever value it had and stick it in that pointer, meaning it would point to some random memory location that would be meaningless, and you would access it and stomp all over some other memory, and it'd be a bad thing. But C lets you do that.
Why do you call the variables defined inside of the structure subfields? Like, what is that field?
It's just nomenclature, it's names.
Alright.
You can call them subvariable, you can call them field, you can call them, in other languages, right?
Yeah.
They call them properties. In other languages, before they were called properties, which had very specific access semantics, they were all called fields. That's the real reason, because historically, any sub-variable is called a field.
Subvariable of a variable?
A sub-variable of a structure. When you get to C++, C#, Java, they'll have something called a class, which is like an advanced structure. This is very similar to a structure. But when they first came out, everything inside of the class was simply a field. They can be private and public and all sorts of other stuff you don't need to worry about now. But they're historically called fields. It's not incorrect to also call them variables or sub-variables, or I'm not sure I care what you call them, as long as when you take the test you understand what is being referred to, number one, and number two, you understand how this is put together. It is this. This is just reviewing that an array by itself without a subscript is a pointer. When you give it a subscript, you have to then give it a reference to make it a pointer. Okay, and lastly, numeric grade. Hopefully this is intuitively obvious after the previous. Num is equal to p not numeric grade. P dot numeric grade. Dot is the usual name for a period in this kind of syntax. P dot field name. To expand this a little further, I meant to do this earlier. I am also initializing struct person pointer p Andy to a reference to Andy. So now we have a pointer with nothing in it. Well, a pointer to a declared variable of type struct person, but we haven't initialized anything. So let's suppose we want to initialize it via the pointer. So we can say Andy.grade is equal to a B. You may or may not be surprised to know that in general I was a B student. What my college professors quickly realized is that my B was worth everybody else's A+, because I had that B for life. Because I never studied for exams, ever. In my entire life, I've never studied for an exam. Because if I knew it, I knew it, right? Well, I mean, I studied the material, right? I never studied for an exam. I studied the material to make sure I knew the material. And the degree to which I knew the material was absolutely reflected on the exam, assuming the exam covered the material. So consequently, I was a B student. But my professors realized what that really meant. So consequently, I was given offices, I was made systems programmer at the university when I was 20, all sorts of things. Because other people figured out what it meant too. The good part is, I could take the final exam without having studied, and I'd still get a B.
Nice.
The problem with our educational system is, they don't understand. They want to see this 4.0 GPA everywhere. That's not a fault of you, that's a fault of our educational system. And how they measure things. Anyway, that's just commentary. Forget about that. Okay. Andy.grade is equal to B. Suppose I wanted to assign a B to that same variable, but using the pointer, p Andy. Anybody want to guess what the syntax is? What syntax can I use to access a subfield via a pointer?
Arrow operator.
The arrow operator is dash greater than sign. That's exactly right. The arrow operator. And then you give it the same name. Except you went out drinking before the exam and killed some brain cells. You got a C this time. The arrow operator is how you access subfields via a pointer. This will be relevant for you in C++ as well. In C# and Java. In C# and Java, we almost never use pointers. In C# you still have pointers available. When they first came out with C# and they showed us that they had pointers available, most of us couldn't believe it. Why would you do that? For the same reason that you have goto in C#. Backwards compatibility, consistency, who knows? I would have eliminated both of them. Well, the pointers have some slightly good reasons. No, they don't. The pointers have reasons to say if you need to get down and dirty with the hardware so that you're doing things in a very performant way. C# is pretty performant anyway. That's why you can use pointers. My response to that would be, don't write in C#. Or write that routine in C++ and bind it or link it in a different way. We actually have pointer code in the apartments.com code I work on. And it's badly written pointer. What's worse is it's badly written pointer code. Fortunately, because I know all about pointers, I could decipher it. The reason I got to see it is because someone came over and said, "What's this doing? I've never seen this before." I said, well, then you should count yourself lucky that you've never seen this before. And then I had to teach him C and C++. And give him a book. The next day, I had to go home and get it.
Is there a way to do that without the arrow operator? Like, do you just put period and then in parentheses star grade?
There are some ugly ways.
I mean, it takes a lot more effort.
Ugly is a judgment, so I'll show you the way. Right? I've dereferenced the pointer. You saw pointer code in C# and gave him a bad attitude, so his next exam got him a D. So you dereference the pointer, and then it's just a person variable, and then you can use the dot syntax.
But are you allowed to do it on the internal components of the struct? So like star grade instead of star pnd? Or ampersand grade, sorry. Because if the answer is no, sometimes the compiler is less clear. That's why.
So the answer is no.
Okay.
The caveat would be, let's suppose we add to this. Well, no, it would still be this. No, because it would still be this. Because even if you, suppose we had a, let's not talk about it now.
Okay. I mean, you said
there's more complication. The answer is no. Right?
Okay.
But there's other things that are like that we could talk about it later. In other words, suppose you declare a pointer in here, right? There's absolutely nothing wrong with saying an pointer called course grades, where you're going to allocate multiple grades. That's effectively declaring an array just in a different way, right? But it means you can allocate it dynamically, because you haven't declared anything, you'd have to allocate it dynamically with malloc. And then to start accessing it, you'd have to dereference it or index it. But the dereference would go all the way outside. That's why, remember when I told you, don't remember the order of precedence of operators, use parentheses? That same concept goes for all of this. Don't worry about what the order of these operators is. Use parentheses so that it's unquestionable what you're doing, number one. And number two, it makes it more readable and more maintainable. Any questions about any of this fun stuff? Okay, let's get started. Any questions about any of this so far? Okay, let's talk about string methods since they will be really useful to you. No questions. Your implicit homework, hopefully you'll come in with questions next week. String functions that will make your life much easier for doing certain things. Right? Like comparing if the input was -1. There are more string functions than these. Right? You will be able to go and read about them. But these are 3 of the main string functions. So, what's the definition of a string by convention in C? That's a good start. Character array. For it to be by convention a string, what do the contents have to have? Either with a null character. The compiler, if you do that, will put the null character in for you. Also, if you are reading using scanf with the %s, the %s tells the scanf method, read in something, and sadly it is up to the first breaking space, right? And then it puts the null character, the null 0, the \0, the null into the result for you. Because it's by convention. That's the convention. Well, let's suppose you didn't do any of this, and you just said, have I got a string in the character array named str at this point? Who thinks yes? Who thinks no? No, you do not. Who's too tired to be thinking? I am. What do I need to add to this to for sure make it a string? And how would I do that? You have to assign it to something, so let's put that down there. Okay, now you've got a string. Why do we go over this and over this? Same reason we go over everything over and over and over. So that it goes in. Okay? Now you've got a string. So for any of these things to work, you have to have valid strings. So string length, strlen. Why are these names so small? Why don't they just put string length? Because they're trying to save space. They're saving space everywhere. In programs and function names everywhere back in the day. That's why those have the names so now. So I have to pass it a pointer to a character array. So I can just pass it str. Because str without a subscript is in fact a pointer. And that would return 3. That would assign 3 to len. Now I'm just hitting the highlights. You guys are going to have to go study this in your implicit homework. String comparison. What do you think we passed to string comparison? 2 strings. You can pass the same string, it doesn't care. They're both pointers, and it just compares character to character to character until they are not equal. And what do you think it returns? It also returns an integer, and it returns an integer that indicates not quite true or false.
Is it 1 and 0?
That's like true and false.
0 and 1.
That's like true and false. False and true. Returns a 0 if the 2 things are equal. This is why I don't completely remember. Let's go look it up. That's the wonder of Google. When you compare, see standard library, just look it up. I couldn't remember if it returned a true or a false, or if it returned try value, like a negative number, a 0, and a positive number. Look at that. I accidentally remembered correctly. It returns try values, 3 values, 3 possible values. As someone said, 0 if they are equal, greater than 0 if the first non-matching character in the first string is greater than that of the second string, a negative number if the first non-matching character in the first string is lower than the second string. This is why I was a B student, right? All these years later, I still accidentally remembered that. So this returns a try-value result. What I just said was lengthy and wordy. Go look it up, read it, and then write little programs to practice it so that you truly understand what the result meaning is. Now, most of you are only going to care about the equal value. Are they equal or not? You don't usually care about how they're not equal, but you do have that discrimination in the result. Most of the times you only care, are they equal? Because you're taking a value in, and you have an array of values, you're saying, is it this one, is it this one, is it this one, is it this one? And that's just the equal comparison. So I get that, for the most part, you're just doing equal comparisons. What is strcpy? Who wants to guess? String copy. What do you think it takes? What parameters do you think it takes? Copying a string? 2 strings. What kind of?
One character array with a string and one that doesn't have one.
Well, it might have one. You're going to overwrite it. In other words, it contains a source and a destination. Now, what is the order of the source and destination? My vague old memory says the destination is first and the source is second. But you know what? That's why we have Google. And the destination is the first parameter. Maybe that should be an A. The only reason I happen to remember that is because it seems backwards to me. But this is how it's defined. Because you usually think of copy X to Y. That's how we think in human terms. But this is in fact the definition. The destination goes first, the source goes second. And I can't remember, I think there might be a third parameter that may be optional that says how much. No, because this is a string. It's going to the null character in the source. What is the danger of string copy? That's right. If the destination is not long enough to hold whatever's in the source, it's just going to stomp on memory. So you always have to do balance checking and see of one flavor or another. Here's a question. I don't remember a string copy returning the result. I think it returns the number of characters copied. No, it does not. It returns a character pointer. A pointer to the destination string. Okay, that can just be used for convenience in programming. It returns a string pointer, a character pointer, which you can think of as a string, right, to the destination. Learn about these, read these, play with them. Don't just read about them. Play with them. Write little programs. So,
What's \0?
\0?
Yeah.
Who can tell me what \0 is? The null that terminates every string. And there's others, right? These are the 3 main ones. How long is the string, which will let you do balance checking that we talked about earlier. How to compare strings, because usually you're comparing for equal. That's the most important one that you're doing. But sometimes it's important, it can be important to know the other one. And string copy, you always do all sorts of string copies. You read things into temporary variables, do whatever you need to do to them, and then put them in their final destination for processing. Very common thing to do in all forms of programming, not just C. Look up string functions. What's the name of the library that contains string functions? Okay, there's a couple actually. That's one of them. What's the other one? I believe a lot of them are in standard library.h. I think string.h has more and is more comprehensive, but I think those 3 are certainly in stdlive.h. But again, implicit homework. Look it up. Play with it, write little programs. Writing little programs is a useful thing. I do it all the time. I mean, just not only for C, but I do it for C#. There's no online compiler for C# too. And I'm teaching data structures like I will be in the spring. There's an online compiler for C++. I think it's the same website. You just choose a different compiler in the dropdown. Very useful. Lets you check things out very quickly, lets you come to understand things. For your purposes, if some of you had just bothered to put your program 1 in and try it, you would have seen that your program 1 doesn't work. Some of you. Some of you, I put program 1 in and it works perfectly. Some of you, I put program 1 in and it worked partially.
STR is string, right?
STR just happened to be a name I chose. At the very top.
Not character, the STR is the one on the
STR, the name of the function is strlen for the first one, strcmp. It is derived from the word string. CMP is derived from the word compare. LEN is derived from the word length. But there's no significance in and of themselves. They're just, they could have called the program XYZ, the method XYZZY.
Are they preserved or not?
Preserve? What does preserve mean? I don't know what preserve means. They're in those libraries. Reserve? No, they're methods. They're method names. Reserved words are things like for, like while, like do, like switch, like case, that are part of the language. These are library function names.
If you call it without having the include statement in the beginning, you're not going to get it. If you define it differently without the include statement at the beginning, and then you call it, you're not going to get an error. Reserved words are something that work even if you don't have any includes in the very front.
Assuming you use them correctly. Reserved words are parts of the language. Right? Remember the very first night I said language, libraries, IDE, or editor, integrated development environment, editor, whatever you want to call it, right? It's important to know which is which. The language has reserved words like while, do, case, switch, so forth. Right? Libraries contain methods like strlen, strcmp, strcpy. Those are parts of libraries. You reference the libraries by some form of include where you give it the name of what you're including. The IDE will sometimes help you sort those things out, or unfortunately, sometimes blur the lines between those in terms of your understanding. But it doesn't mean all of that doesn't apply. Reserved words are part of the language. Function names are part of the libraries. And you can't use, in general, you can't use reserved words as variable or function names.